So in this video we are going to discuss about method of electrical image, and using this method we are going to find these things. Here you can see induced surface charge density, force of attraction between the charge and plate, and total induced charge. So here suppose we have a charge q at a distance, suppose d, from this plate AB, which is at zero potential. So which is at zero potential. Okay, this is a infinite plate conductor, and this charge is at q, which and this plate is at zero potential. Now you see how to use the electrical image method. So here we're going to assume that we have placed a minus q charge, and which is at the same distance d from the plate on the other side of the plate. Okay, and so that it can be regarded as image of this charge. Okay, this is the image of this q charge. Hope you have understood this. Now you see, to find the surface charge density, okay, so we're gonna find the electric intensity at P. So let me take a point here, P. Okay, on the plane, on the plate we're gonna take a point P, and here we're gonna find the electric intensity. Okay, electric field intensity due to these two charges, plus q and minus q. Right, for that purpose let me take join these two. Okay, right, let me use dotted line here. Okay, now you see what we can do here. The direction of the electric field due to this positive q charge, this q charge is positive, that will be in this direction, and the electric field due to this negative q charge will be in this direction, because for negative charge it should be towards the charge, and for positive charge it should be radially outward direction, away from the charge, right, in this direction. Hope you have understood this. Right, let me draw it properly, just give me a second. Okay, this is the direction due to the positive q charge, it is due to the negative q charge. Right, hope you have understood this. Then the resultant must be in this direction. Okay, then the resultant must be in this direction, and if this angle is theta, then this angle must be also theta, and that one must be also theta, as we are taking this is an equilateral triangle, because this side, these two sides are equal, and this is perpendicular. Okay, and so that's why this angle is equal to this one, corresponding angle. Okay, and this angle is equal to this one, alternate interior angles. So both angles going to be equal to theta. So here this is here this AB, the plate, is in such a way that this is the perpendicular bisector of the line joining the two charges q and minus q. Right, so hope you have got the idea of the geometry of this figure. Okay, so in that case, if we take this case, then what will happen? Now you see, then this will be the EQ sin theta, this component. Right, there will be two components of this electric field, one on this side, that will be EQ cos theta. Similarly, for this electric field which is towards the negative side, so for this one also, U minus Q cos theta, E minus Q cos theta in this direction. Okay, in this direction, and another will be in this direction, which is downward, E minus Q sin theta, sin theta. Right, that's what we're gonna have. So hope you have understood this. And these sign components are equal and opposite, so these two components will be cancelled. Right, this one and this one will be cancelled. Okay, and here you see, let me tell you one more thing. This here you see, if these distances are, then this distance is also r, is smaller. Okay, So at this point, electric magnitude of this electric field, that due to Q will be equal to, you know, kq by r square. Similarly, due to this minus q also, at this same point we're gonna get E minus q is equal to kq by r square. Magnitudes are same, so that's why these two are equal in magnitude but opposite in sign, so that's why the sign components will be cancelled out. So that's why the resultant of the resultant electric field at P, okay, so that resultant electric field at P, resultant electric field at P, that's going to be equal to 2 eq cos theta, and eq will be equal to kq by r square, okay, kq by r square cos theta, okay, kq by r square cos theta, right? So now you see here, now you see from this triangle, if you take this triangle from here, what you can write? You can write cos theta is equal to d by r. So you can replace cos theta, this cos theta, d by r. So instead of cos theta you can write d by r. So that's why, so let me write something here. So here this is electric field E, net electric field at P, okay. So E is equal to, what we're gonna have, 2 k q by r square into dr. So that's gonna give you 2 k q by r cube. That's what we're gonna have, right? Hope you have understood this. Now let me copy this step and let me go to the next slide. So here is the last step we have got, and you see, okay. So now what we're gonna do, we know that the k is equal to 1 by 4 pi epsilon naught, right, q. So I forgot to write the d here, okay, q d by r cube, okay. So let me write here d. So now it cancels this. So what we have got this, that 1 by, or you can simply write qd by 2 pi epsilon naught r cube. That's what we're gonna have, okay. And by Gauss law, we know that electric flux, that is E dot, or simply write, let me write E integration of ds is equal to q by epsilon naught. So as we are taking here positive charge, so charge induced on this surface will be negative, so that's why we're gonna put here negative sign, okay. Then it's gonna be equal to minus q by integration ds epsilon naught. So this integration ds represents the area, so q by this, that's going to be equal to sigma, surface charge density, sigma by epsilon naught, where sigma is surface charge density. Right. So therefore from these two relations, this one and this one, what we can write? We can write, instead of E, we can write q d by 2 pi epsilon naught r cube, and that's equal to sigma minus sigma by epsilon naught. So therefore here epsilon naught gone, so sigma is equal to minus q d by 2 pi r cube. So this is the induced charge density on the surface, right? So hope you have understood this. Now let me calculate the force of attraction between the charge and the plate, okay. So how to calculate that? Okay, now you see, Now you see the force exerted, uh, on the charge q by this surface will be same as the by the induced charge on the surface will be same as the force between this q and this minus q and this plus q, right? So that's why what we're gonna do, using Coulomb's law, we can find that the force exerted on the charge plus q by the induced charge on the plate is the same as that exerted by the image on the image means that minus q charge on plus q, because the image is actually not there. Okay, so whatever with the forces arises due to the induced charge on the surface and the charge placed at a distance t. Okay, so that induced charge is imaginary in this case, so that's why. So here F is equal to, so minus, so we have two charges, positive q, negative q, and that's a q square, and here we're gonna get 4 pi epsilon naught. Now distance between the two charges is d plus d, that's gonna be 2d, so 2d whole square, that's gonna give you minus q square by 16 pi epsilon naught d square. This negative sign indicates it is attraction force, so negative sign indicates attractive force. Okay, so now let's find the charge, total charge induced on the surface. Okay, so before we find the total charge induced, let me tell you something. Suppose here you see, so now this is the infinite conductor plate. If you imagine like this is the plate, suppose. Okay, and here is the charge q. Now charge induced on this plate due to this q charge will be negative, because this is positive. Okay, now you see, suppose, let me draw a perpendicular here to this point. Now suppose this charge due to this positive q charge, so charge induced up to this distance, suppose from this center is, suppose a minus charge is induced to this distance is, suppose this is the r distance or x distance, whatever you take. So same amount of charge will be induced on the other side of that, from this point. Okay, similarly, if negative charge is induced on this side, then at same distance another negative sign will be induced at. So this will be circular. Okay, so that means this will be the region in which the charges will be induced on this plate, that will be circular. You can consider that way, right? So now you see, so to find the charge induced on the plate, now let me consider this plate AB in this way. Let me draw it this way, AB. Sorry, just give me a second. So this is the plate, suppose. Okay, this is the plate AB, and here is the charge Q, and this is the distance D. Okay, and here is the circle. Okay, So now you see, so let me take this radius is suppose x. Okay, now you see, let me draw a strip, actually circular strip like this. Okay, now here you see this is a very small element, area element here. Okay, and this is very small area element and produce very small angle d theta here, d theta. Okay, and now you see this part, length of this arc, that's going to be equal to, if this angle is d theta and this radius is r, then in that case length is x d theta, right, x d theta. And let me consider this thickness of this strip. Let me consider this thickness of this strip be suppose dx. Okay, let me take this is very small thickness element. Okay, dx. So let me make it very small. This is suppose dx. Okay, now in order to find the charge distributed over this surface, so how to find it? Charge, total charge induced on the surface, that's gonna be Q is equal to integration, and here you see charge density is this, and we're gonna take the area element, this small area element. Okay, this small area element is, suppose let me take this area element dA. Okay, so dA is a very small area element, very small area element. Okay, small area element of the circular strip of radius x and produces angle d theta at the center. Okay, let me consider that. Now you see we have to integrate this in the radial direction as well as through this angle. Okay, hope you have understood this. Okay, now we have got sigma is equal to, where is the sigma? Q d by 2 pi r cube. So let me put here minus q d by 2 pi r cube into dA. So dA will be equal to, so area of this one. So this length is, here you see this is the small strip, and this length is x d theta that we have already I have already explained this, and this thickness is dx, so its area will be x dx d theta. That's, so dA can be written as x dx d theta, x dx d theta. Okay, so hope you have understood this. So now you see, and the r is the distance from this q, okay, to the point P. P is on P was on the plate, right? Point P was on the plate. Okay, so this distance is r. Okay, so let me consider here is the point P. This point here you can see in the diagram, this point I'm talking about, this point. Okay, right? So in that case the r cube, so here you see r square gonna be equal to x square plus d square. So then r will be equal to x square plus d square whole to the power half. So that's why r cube, that's gonna be equal to 3 by 2 power. We're gonna have power on this term 3 by 2, right? So hope you have understood this. So if we do that, then what we can do here, you see we take out the terms. Okay, this is dx, and this d is distance, this distance. Okay, and this is not that distance, this is dx. Okay, so hope you can recognize the difference between this. So this is x, this is dx. Dx is the small thickness of the string. Okay, so 2 pi is taken out, then r cube means here we're gonna get 1 by x square plus d square whole to the power 3 by 2. Then we're gonna have so here we have to do surface integration. Okay, then we're gonna have so x dx d theta, right? Hope you have understood this. Now how to do that? So let me copy this last system and let me take a new slide. Okay, and let me copy the diagram as well. So here is the diagram, right? So surface integral, we can represent it by two integral symbol. So let me write here qd. Here we're gonna have 2 pi, and one is 0 to theta. So here we're gonna integrate this d theta part, then another, and you have to integrate it, actually not only theta, you have to integrate through the angle from 0 to 2 pi, right? To complete the circle we need to integrate it from 0 to 2 pi. Then this is an infinite plate, so we're gonna integrate it from the center, which is 0 to infinity. Okay, 0 to infinity along the radius, 0 to infinity, right? So hope you have understood this. So what we're gonna integrate x dx divided by x square plus d square whole to the power 3 by 2, right? Hope you have understood this. Now you see what we're gonna do here. Now if you integrate d theta, then you're gonna get theta minus qd by 2 pi. You're gonna get theta, and we are integrating it from 0 to 2 pi. Then if you integrate this, how to integrate this I will show you. First let me write this one as it is, whatever it is. Okay, so now let me go to new slide. Now you see, if you put the upper and lower limit here, we're gonna get minus q d 2 pi minus 0, that means simply 2 pi. Okay, 2 pi by 2 pi, here 2 pi will be cancelled, so we're gonna end up getting this 0 to infinity x dx divided by x square plus d square whole to the power 3 by 2. Now let us suppose let x square plus d square is suppose t. If we differentiate both sides with respect to x, then what we're gonna get, twice x plus 0 is equal to dt by dx, and that's gonna be equal to dt is equal to 2x dx, or you can say dt by 2 is x dx, right? So that's why this term will be equal to q minus qd, right? Minus qd integration 0 to infinity x dx will be replaced by dt by 2, and this term going to be replaced by t to the power 3 by 2, right? So as x square d square is equal to t, we have considered that way. So that can be written so half can be taken out, qd by 2 integration 0 to infinity. So here we're going to have 1 by t to the power 3 by 2 dt, so it can be considered as t to the power minus 3 by 2. Okay, now apply this one, integration x to the power n dx is x to the power n plus 1 by n plus 1. If we apply that, then what we're going to have, qd by 2 and integration of that t to the power minus 3 by 2 plus 1, that's going to be minus 1 by 2 by minus 1 by 2. That's what we have got, 0 to infinity, right? So hope you have understood this. Now you see what we can do here. So this minus will be plus, and these two cancels this. Then here we're gonna get q d, then 0 to infinity to 0. So here we're gonna have 1 by if you make the positive if you take the positive power, that gonna be 1 by t to the power half. T to the power minus half is t to the power 1 by t to the power half, that is 0 to infinity. If you put infinity here, that's gonna be 0, and if you put 0, that's gonna be infinity, right? And let me do one thing before we put the limits. So what we need to do is here you see we have to change the limit as well, actually not only this. So when we had x, when x tends to 0, when x becomes 0, t tends to d, right? So we have to change the limits here. When you substitute here, we're gonna have when x is 0, t becomes d, and right, sorry, not d, d square, t becomes d square, right? If you put 0 here, t will be d square, and if you put infinity here, then t will be infinity. So it's supposed to be d square to infinity. Okay, d square to infinity, right? D square to infinity. As here we have to write, as x tends to 0, t tends to d square, right? So that's why we have changed the limits. So here it's supposed to be d square. Okay, on putting the upper limit, we're gonna get 0, right? So then we're gonna get q d. On putting the upper limit, we're gonna on putting on infinity, we're gonna get 0 minus then 1 by t square whole to the power half, right? Because here we have t to the power half, so that's what we're gonna have. So let me take a new slide to explain this. Just give me a second. So here is a new slide. So this is q. So q d, if we put 1 by alpha infinity to the power half, that's going to be infinity again, minus 1 by d square to the power half. So here q d, so this becomes 0, so we're going to have minus 1 by d, right? So this d cancel, so we're going to get minus q. So that is the charge induced, total charge induced. Okay, so this is the total charge induced on the plate, right? Hope you have understood this. Thank you for watching. See you in the next video. Bye bye.